Hi. In this video, I'm going to show you an example of how to write a linear system from a problem, and then I'll show you how to verify a solution to that linear system. Okay, so in this question, we see that a recent band concert raised $786 from ticket sales. 52 adults and 74 students attended, and adult tickets cost $3 more than student tickets. So the question is, what were the prices for adults and student tickets? So what I'm going to do here is we'll represent the situation with a system of linear equations, and then we're going to verify that this solution here makes sense, and that is a solution: $8 for adults and $5 for student tickets. Okay, so if we're going to represent the situation with a system of linear equations, first of all we have to choose what the variables are going to be. So sometimes people will guess that the variables should be how many adults and how many students attended. But those don't make sense to have as variables because we know what they are. 52 adults attended and 74 students attended. So the next thing you think, well, often what we should have the variables will be is what the question is asking. Not always, but often. What were the prices for adults and student tickets? And this makes sense because we know that there's an adult and a student price. We know some information about how much more adults are and how much altogether they were raised. But we don't actually know what the prices were. So we'll let A represent the price for an adult ticket. And we'll let S represent the price for a student ticket. So we're going to have two equations here. One is going to be about how much they raised altogether, and the other one is going to be about this information: adult tickets cost $3 more than student tickets. I think this might be a little bit easier, so let's start with that one. Adult tickets are $3 more than student tickets, so that means that the price of an adult ticket is the same as a student ticket and then $3 more. So it'd be student ticket plus 3. So for example, if a student ticket was $2, 2 plus 3 would be the adult ticket would be $5. So now the second equation is a little bit more complex. We know that altogether we raised $786. Maybe I'll do this in a different color. $786 altogether, and we know that there were 52 adults and 74 students. So if I figure out an expression for how much the money we should have raised with 52 adults and 74 student tickets, and then that should be equal to 786. So for 52 adult tickets, we'd raise $52 times the price of an adult ticket. And in this case, the price of an adult ticket is A. So 52 times A, because that's the number sold times the price. So that's how much we made for adult tickets. And then for student tickets, it's 74 times the student ticket price. So that's how much we made for student tickets. And then if we add those together, the amount for adult tickets and the amount for student tickets, we should get the total amount raised, which is 786. Okay, so we've got the system of linear equations. Part B asks us to verify that $8 for adult tickets and $5 for student tickets is a solution to the system. So we can either verify that it's a solution to the system, like it asks us, so we'll check that it fits these equations. Sometimes though, if you've written the equations yourself, especially if you're not quite sure about them, sometimes it's better to verify that it's a solution to the situation up here. So sometimes it'd be better to say, okay, do adults tickets cost 3 more than student tickets, and if we did this, would we get this price? Just in case you'd made a mistake with your equations. The reason I'm going to use the equations right now is because I'm sure they're right, and because this is usually the place where people usually have a little bit more trouble, just because it's a little bit more formal. So for equation 1, so remember, we can't just, what we have to do is check, do these values make these equations true? But we have to be a little bit careful about the way we write it so that we're not like declaring that things are true without checking. So first of all, I guess I'll say that this $8 for adult tickets means that A is 8, and this means S is 5. So in equation 1, the left side of the equation is equal to A, and A is equal to 8. The right side of the equation is equal to S plus 3, and that's equal to 5 plus 3, and that's equal to 8. So my left side equals my right side, so this is perfect. That means that A equals 8 and S equals 5 is at least a solution to equation number 1. Now for it to be a solution to the system, I've got to check that it also is a solution to number 2. So my left side of the equation is equal to 52A plus 74S, and that's equal to 52 times 8 plus 74 times 5. I'll pull over my calculator here. 52 times 8 plus 74 times 5 is equal to 786. So my left side is equal to 786. And the right side of my equation, which is everything right of the equal sign, is also equal to 786. Oops, 786. So the left side is equal to the right side. Okay. So when you're verifying, just be a little bit careful that separate the left side, figure out what the left side is equal to, figure out what the right side is equal to. Often, like in this one, it's really easy, it's just the number. And then check if they're both the same. Do this instead of just writing down the equation and substituting, because if these numbers were not a solution, then you'd be writing something that was false. Okay, good luck.